Hi guys, Mark here, and here we are on day 24 of the Advent of Code Challenge. Just one more day to go, and today's one wasn't too hard. I got it done in about 20 minutes thanks to reusing some code from a previous day. I didn't get up super early this morning though, so no chance of being on the leaderboard. And what we're doing today is basically Santa's got a load of presents of different weights, and you can see here the weights of my presents are prime numbers, but with the odd one missing, so 11 is missing. And Santa needs to sort them into three groups, and each group has to be the same weight. Okay, so there might be many ways to sort these out, and to decide which group goes in the passenger compartment, it must have as few packages as possible. So we're looking for the smallest group, and if there are two groups with the same number of packages, then we multiply them together, their weights together, to get the quantum entanglement, and we're looking for the smallest quantum entanglement. So basically, let's have a look at the C# code that I wrote to solve this, and I reused this function with a slight modification that I wrote on day 17 to find all of the ways that we could fill our containers with 150 litres of eggnog. And this is a similar problem. All the ways we can add up to a specific weight out of our presents. So I'll come back to this in a minute, but let's just look at the algorithm. So we need to sum together the weight of all of our presents and divide it by the number of groups. We're dividing our presents into three groups, but part B, there are four groups of presents. And that tells us how much weight each of the groups of presents needs to be. And then basically, I'm going to pick out a sequence with my distribute function of groups of presents that add up to that amount. And I've got this best so far value to keep track of what the smallest group that adds up to that amount is, so that we don't go calculating lots of redundant groups. It's just an optimization technique. Once we've got all of those groups, we select how many elements are in the group, the count, and we also multiply them together to get this quantum value of some kind, and we can do that by aggregating all of the ints by multiplying each pair together. And I did have to go from ints to longs here because I got overflow with my input if I multiplied everything together. And then we order by the count and then by the QE, which I've forgotten what that stands for now, and pick out the first one. So not too complicated. Let's just have a look at my algorithm that I say I borrowed from day 17 of finding out the ways. It's kind of a combinations algorithm really, of picking elements from a set whose values add up to something. And you could, I suppose, use a power set function which picks out every possible set and then filter out only the sets that add up to the value. But that would require calculating a vast number of sets that didn't work. And so this is just an attempt to optimize a little bit. I have a list of the used presents and the pool of available presents and the amount I'm going for. If we've already used more than the smallest group of presents, then we can just break. Otherwise, we work out how much weight remaining we have and go through all of the presents in our pool and see if that makes us up to the required amount. If it is, we return the list having added that present. Otherwise, we discard this present, we can't use it, and we recursively call ourselves with the same list of presents we've used and a reduced list of presents we've used. And this got me the right answer. One thing I should note is that really after finding the smallest group that adds up to the value, we should have checked that the remaining presents could be divided equally. And it turns out a lot of people made that mistake, although it didn't actually matter. The remaining presents for the winning combination could always be divided up equally, so it didn't cause a problem. Let's just have a quick look at how I did this in F#. And again, I was able to start with the distribute function that I made in my F# version. I did have to have this mutable best so far. I couldn't see a good way of working around that. Otherwise, the algorithm takes a long time to run. But basically, apart from that, if the length of the used list is greater than the best so far, we just bomb out. Otherwise, if we manage to make exactly the target, we return the list of used items that makes that target. Otherwise, we recursively call ourselves, trying to find more solutions. And then the find best QE function, again, very similar to the C# version. We work out the total weight of our presents and therefore the weight per set or group of presents. Give a starting best so far. And by the way, this is another speed optimization. Instead of using something like int.maxValue as the best so far, I just use the number of presents divided by the number of groups plus 1, because the smallest group is always going to be less than a third or a quarter in part B of the presents. And so then I call my distribute function to get all of the possible groups of presents that add up to that amount, map them to get the length of each of those groups of presents, and use reduce on multiply to get the QE. And then one of the nice things in F# is you can sort by a tuple, and that's like in C# doing order by and then by. So it'll order by the first item in the tuple and then by the second, and then just pick off the head from that list. And so that returns the right answer. As with C#, I didn't go and check the rest of the elements and make sure they divided up equally. Probably you could improve on this algorithm, and looking at the answers on the subreddit, many people have improved on this. What would be sensible is to start off by picking out a set of 1 present that adds up to the total, and then if you can't do that, look for a set of 2 presents that adds up to the total, and then 3, and so on. And I did see a few solutions where people were doing exactly that. And that would be a way I could get rid of my mutable best so far variable, because I would always be checking the smallest set sizes first. But anyway, that's day 24 done. We're nearly there. Hopefully tomorrow's challenge won't be too hard. I can't promise I will find time to solve it. Tomorrow is of course going to be a very busy day with all of my children opening their presents, and we'll have a new Wii U in the house to play with. But hopefully I will find a few minutes, if it's not too hard, to solve this last problem. And happy Christmas to you all, and thanks for watching this series so far.